Hello everyone, welcome to this fourth video on Python. In this video, I will cover two very important functions which we use frequently while doing any data analysis. And those are value counts and sort values. Before getting into the details of those two functions, we'll start with columns function which we use in any data frame to get the names of the columns of the data frame. So, and in this video also we are using the same data set, sleep health and lifestyle data set, which is available on Kaggle. And also the details of these functions are available on these links on the official documentation of these functions. So let's start. So before loading the data, we'll load this library pandas as pd, and then we'll load the data from the CSV file which is already there in my environment. Now, as usual, as we have seen in the last video also, when we load any data set, we should quickly take a look at the shape of the data set to understand how many rows and columns are present in the data. Then we should also check what are the column values. So that also we can do by using head or tail. But yeah, we can also write this function sleep.columns, and we can get the list of the column values present in that data frame. So you can see that it is person ID, gender, age, like that. These are the column values, and we can also convert it into a list you by adding this two underscore list at the end of these function call. This is also useful many a times. We'll see later in the coming videos how we can use this. Now, checking the first few rows, that is very important to get some idea about your data set. So we'll do sleep.head. We'll check the first 10 rows here. So after that, we can just take a look at the data types present in this data frame, and then with sleep.info we are able to get that idea, and then we will just convert person id to string. Okay, now let's jump into the first important function, which is value count. So some of the important arguments in this function are normalize, sort, ascending, bins, and drop in. So normalize, by default it would be false, and when you set it to true, actually it will give you not the count, it will give you the percentage distribution of the records in that particular column. Sort by default is true, so it will give you a sort data set in descending order. So by default ascending would be false, and it will give you the data in the descending order. Bins, if you specify the number of bins, actually it will bucket your numeric data in those many bins, and it will give you a count. Drop in, actually, if you uh, by default it is true, so it will not give you the count of NaN values. Okay, so it will exclude that. Let's see this data frame again. So here, now, by looking at this data frame, few of the questions that we can start answering is like, what is the distribution by gender? So we have how many rows? We have 373 374 rows and 13 columns. So those 374 rows, how it is distributed among male and female, and is there any other value other than male and female as well? So that also we can get to know by looking at the distribution by gender. We can also see what is the most common occupation present in this particular data set. We can also answer this question, what percentage of records are overweight by BMI category, if we just look at the value counts there. And we can also see which age groups has more number of records. So let's try to answer a few of these questions. So the code here is very simple. So when we are looking at gender distribution, we'll just take the data frame and the column. We'll select this column because we want to do value counts on this particular column. And by default, we are not actually using any other argument in the function. We are just taking all the default values and see, let's see how the results look like. So you see, it has provided us a distribution. So male records are 189 and female records are 185. Now, so it's around 50% records are male and female, and there are no other different kind of values present here. Uh, it's not like some of those records, gender information is not available. Those kind of cases are not present here. Now, so this answers the first questionnaire distribution by gender. Now, we want to see which is the most common occupation. Again, if you do just default value counts on this occupation column, let's see what the result is. So it's by default it is sorting in descending order on the basis of count. So we can see that nurse is the most common occupation present in this data set, followed by doctor and engineer, like that. Okay, so just the default value counts. This is very useful function to understand what kind of values are present in the data set, and then few other things also you can do. Now, if you want to see the distribution by BMI category, so the third question was percentage of records which are overweight. So if we just do value count, we'll get the count of records. To get the percentages, we'll use normalize equal to true. So it will give us the normalized value. It will actually divide these counts by the total number of rows to give us a percentage. And I'm just using this round function to actually round it to three decimals. And when I multiply it by 100, actually it will give me some proper percentage kind of value. So when I run this, see, the results are like this. So overweight are 39.6 percentage of records are overweight. So we can answer these types of question as well uh, by value counts. Now, what if you want to sort this data? You don't want to get a result in descending order. You want it in ascending order. So in that case, you'll have to use this argument ascending equal to true, because by default it sorts in descending order. So when you mention ascending equal to true, and then you'll get it in ascending order. So if you see obese, which has the lowest percentage of records in the data frame, is at the top, followed by normal, weight, overweight, and then normal, which has the highest percentage of data. Now age, if you see age, this particular column age, these are all numeric values. So if you want to get some distribution of age, we can build a histogram as well. But yeah, using value count, if you specify the number of bins, it will group your data in those many buckets and it will give you a count. So the highest count is in 39.8 to 46.2 age bucket, and it is 103. And if you see this interval, it is closed on the right side, but it is not closed on the left side. In the left side, so it's all greater than 39.8, including 46.2. It's like that. So in this bucket, we have the highest number of records. So you can see how important this value count function is. You get more information about different columns in your data set, and then based on your requirement, you can sort it in ascending or descending order, and you can actually normalize it also to get the percentage distribution. Now the next important function is sort values. So by using sort values, you can sort a data frame, you can sort a summarized data frame, anything you can sort. So these are the important arguments there. By, so by which column you want to sort, you need to specify. Axis, it's by default 0. We generally don't make any change to the axis argument. Ascending, by default it would be true. If you want it in descending order, you'll have to change it to false. In place, again, this is an important argument, because after sorting, do you want to actually save that sorted data frame? So if you do in place equal to true, it will save that sorted data frame. Otherwise, you'll have to assign it to another data frame if you just want to save that sorted data frame in any other variable, okay. And then kind, by default it is quick sort. We don't generally make any changes here. In a position, by default it is last. So the sorted, while sorting, it will keep the records with any values in the last. And then ignoring index, uh, by default it's false. And then key function is also there, which we again generally don't use, but yeah, you can get into the details of these arguments by looking at the official documentation. So let's see again, let's see some columns and see on which columns we should try sorting the data. So yeah, so let's sort the data by age, by sleep duration, by quality of sleep, by stress level, and then combination of these columns. So first we'll see the results by these individual columns, and then we'll use a set of columns to sort the data set. So let's start with age. So I'm sorting this data set by age. So if you see the smallest age, which is 27, the records are sorted in a way so that it is at the beginning. And this is a sorted data frame you can easily actually identify by looking at this index column. By default, the data, so by looking at the index column, you can identify that it is sorted in some different way. By default, it should be in increasing order of index values from 0 to 373, but now it has changed. After 5, it's going to 18, 17, 16, 15, like that. And if I look at the last few rows, it's 58, 72, 64, 73. So in that order, these are the last few rows. So this is how it is sorted by age. Now, if we sort it by sleep duration, so you see, so the minimum sleep duration here is 5.8, and this is how the sorted values look like. So 81st index, which would be I think 82nd row, is having the minimum sleep duration. Actually, there are few other rows as well. So 82nd and 81, they are having minimum sleep duration. And the age here is 34. The minimum sleep duration, their quality of sleep is again low, 4. Physical activities seems to be less, and the stress levels are high. Now, so these are all ascending order because we had not mentioned ascending equal to false. If I sort by quality of sleep, okay, so if you see the quality of sleep, the minimum value is 4 and then 5, like that. And again, the 88th index, which is the 81 uh, person ID, it has the lowest quality of sleep. There are a few others as well, but yeah, it has the lowest one. It also has the lowest one. By stress level, if I sort, then you see the stress level is minimum for age 59, and that particular lady is a nurse and has good sleep duration as well. It's kind of related. We'll look into those relationship etc as well later in some later videos. And if you want to actually sort it in decreasing order, then you just need to mention ascending equal to false. So let's run this cell. So stress level minimum is 3. Let's see what is the maximum stress level and how does the records look like. So maximum stress level is 8, age 32, doctor, and the sleep duration is again less. The quality of sleep is also kind of less. Physical activity is also, it seems, less. So here for engineer, this engineer of age 53, female engineer, physical activity is less. Still, the stress level is also less. I think because of good sleep quality and sleep duration. So by sorting the data, also you can get some more sense of the data that you are going to analyze. Now, what if you want to sort by combination of columns? So we just run this. So by default, it would sort the values in ascending order. So it will first sort by age, then stress level, then sleep duration. So if you see, it's 27, which is the minimum age, and then stress level minimum for that 27 case is 6, and the sleep duration minimum is 6.1. The next case is 28. So there are a few 28 age records. You see, 3, 4, 5. If you look at these are all 28, right? But again, it is sorted by stress level. Their stress level is 8. So there is no difference here. But yeah, after that, we have some 6 stress level cases as well. Okay. And then sleep duration, if you look at the sleep duration, so for all this age 28 cases with stress level 8, the sleep duration is again in the increasing order. And then after it moves to 29, in 29 this minimum stress levels are like 6, and the sleep duration is kind of starting with 7.8. Okay, so this is how it sorts by default in ascending order. First age, then stress level, then sleep duration. So here we can even change uh, the order as well. So if you want age decreasing, here it would be age descending order. Stress level, we can change it to ascending order. So ascending would be true, and then sleep duration would be in descending order. Let's see how the results look like. So here we are sorted in descending order of age. So the highest age cases are at the top, 59. Then stress level should be minimum. So yeah, it's like 3 for all these 59 cases, starting with 3. But the sleep duration is descending. So they all have good sleep. So it starts with 8.2 and then 8.1. It's like that. So you can sort your data frame by different combination of ascending, descending for different columns. You can specify and use it as per the requirement. Now this is the sorted data frame, but what if you want to store it? So there are two ways. So one is you can just create a new data frame. You can mention it to be something like data frame sorted. It would just store that data frame and then you can use it further. The other way is to use the argument and sort values, which is in place equal to true. So if you do that, it will sort the data frame and store the results as well. And then quickly you can use the same data frame, in fact, for further processing. Now, once you have sorted the data frame, what if you go back to the original state of the data frame where the index started from 0 to the in number of rows? So for that, you can use this function sort index. Again, the details you can see in the this reference document. But yeah, a few important arguments are access, ascending again, in place, and ignore index. So access by default it would be 0, and ascending by default it would be true. If you specify false, it would do it in descending order. In place by default it would be false. We have seen earlier as well. And if you ignore the index, it will create new index for you starting from 0. So now let's look at this index present in this data frame sleep. So now because it is sorted, you see the index start from 360, and then it's not in proper order right now: 361, 62, 63, then you have 59, 66, like that. Now what if I just use the sort index, the default, with default argument values? So it has sorted, in fact it has sorted the data frame, and you see the index are in 0, 1, 2, 3, 4, 5, 6, like that. But yeah, I can just mention ascending equal to true, and then it will give me the same kind of result. But yeah, when I am also specified in place equal to true, it will store that data frame as well. It's not just only sorting, it will store it in the same data frame, and then we can use it as per our requirement. So again, with this example, you can understand that index column also becomes important, because if it is not in a proper way, you can easily identify that some transformation has been done on the data frame. And what if you do x is equal to 1? Let's see. You see, then it sorts the columns. Okay, and it sorts the columns on the basis of name. So the column starting with age is first, then starting with A is first, which is age, and then B, C, D is like that. So this is how the columns are also sorted. If you want to do that, you can use sort index with access equal to 1. Okay, so that's all from this video. I hope you would find it useful. Do subscribe my channel and like the video. See you again in the next video with some more important Python function.